Okay, these are some of the notes I passed out on finding the vertex of a quadratic equation when it's in standard form. So first I'm just going to go over these notes just in case you didn't get these in class. You can take a look at them now, you can zoom in, and I'll just talk through what I talked through in class. And then the next video I'll actually do an example showing the graphing and answering all these other questions that you're supposed to do. In other words, you need to find the vertex, which is what we're going to talk about first, and the x-axis symmetry, the maximum or minimum value of the y-intercept. A lot of these are real easy. The x-intercepts are going to be a little bit more challenging, and I'll explain the domain and range, and then I'll also graph it. So again, if a quadratic is in standard form, and that's in this form, okay, f of x equals ax squared plus bx plus c. Now we've seen the vertex form, but this is in standard form where here we have the x squared, x, and numerical term on one side, and then just the function notation on the left side. And in this case, we could also call it y equals ax squared plus bx plus c, because y is the vertical position on a graph. So when we graph it, we might call the value of the function y. And the horizontal position, or the domain function, is x. So this is domain, range, input, output, and the output is the whole thing. And in other words, this is a rule that takes our domain element x and does some things to it. In other words, in this case, if whatever the function says, f of something, in this case x, is a times that something squared plus b times that something plus c. And then we could put different input in to get different output. So again, this is the domain element, x, range element, all this, whatever we do to x, the result, okay, or input, output. If we do have it in this form, we have a very nice equation, and we actually derive this in calculus. So when you take calculus, we'll show you how to derive this. The x-coordinate of the vertex is given by this formula, x equals negative b over 2a. That is, the vertex is the point negative b over 2a and something. In other words, the something is the output we get when we put this input into this rule. Now again, I always emphasize this. Remember, the y-coordinate of a point of a function can be found by evaluating the function at the x-coordinate of that point. There should be a space there, sorry about that. So that'd be the function at the x-coordinate of that point. And I wrote this different ways you can notate these. Now remember, a function is a set of ordered pairs. So we could say that this ordered pair xy belongs to the function. Remember, the epsilon means belongs to, so xy belongs to the f. It also can be written as, and this means implies, f of x belongs to f of x. In other words, x, input, output, domain, range, also belongs to f. We could also write it like this: x and the whole rule belongs to f. And this is the unordered pair. And this is our domain, this is our range, or this is our input, and our output is what we obtain after we put the input into our rule or our various mathematical operations. And now in this case, we could write the vertex is, and this is the x value we find by this nice equation. And then if we put that x value into the rule, which I'll show you in just a moment, we'll find the y value. Now this notation might seem a little confusing. If you look at this first, it might be a little bit easier. And then this is after we can find the value of the function, or the y-coordinate, by putting the x value into the rule. And we'll show you an example. So here's an example. If f of x equals x squared plus 4x plus 3, now this is in standard form, find the vertex of f of x. So first of all, let's identify the a, b, and c. So the a is 1 because it's just 1 in front of x squared. It's 1x squared. The b is, so the a is 1, the b is 4, and the c is 3. So in order to find the vertex, we use this nice formula, x equals negative b all over 2a. Negative, and then b was 4. 2 is in my formula, and a was 1. So I put that right in. I've got negative 4 over 2 times 1, which is just negative 4 over 2, which is negative 2. So there's my x value of the vertex. All right? So right now I know the vertex is -2 something. Now I don't know what that something is, So how do I find the something or the y value or the range value or the output when I put this input? Well, I take this input value and I put it into this rule. All right, this rule says f of something squared plus 4 times something plus 3 will give me my output whatever the something is. So in this case, the something will be -2. So I'll put the -2 in the rule. So I've got -2 squared plus 4 times -2 plus 3. And then -2 squared is 4. 4 times -2 is -8 plus 3. So I've got -8 plus 7 is -1. So that's my f of -2, or that's my y value of the vertex. So the vertex is at -1. I'm sorry, -2, -1. And you can see that this is the idea. See, this was going to be -2, and then if I take -2 and put that into the rule, I get the output, or the y value. So there's my vertex. Now you have all these questions. Now a lot of these questions you could answer because we've talked about this before when these were in vertex form. This is xy. And the axis of symmetry is just x equals -2. All right, it's very easy, and that's a line. It's a vertical line, x equals -2, and it's right there. So you see, when you see the vertex, you can actually see the axis of symmetry just by saying x equals -2. Now, the maximum or minimum. Now, we just have to look at the first term. And remember, if the first term is the x squared term, or in this case, the a is positive, okay, my parabola from our experience is shaped like a U. If it's shaped like a U, we have a minimum. Now, if the a is negative, if we have a minus in front of the x squared, it's shaped like an n, and an easy way to remember that is n and negative both start with the letter n. So if this is negative, it would be shaped like an n. Well, if it's shaped like a U, oops, sorry, you can't see that. If it's shaped like a U, okay, we have a minimum. It will go down just so low that it's going to go back up. It won't have a maximum because this will go up and up forever in both directions, but it will have a minimum value. If it's shaped like an N, it will have a maximum value. It goes down and down forever, but it only goes up to a certain point, so it will have a maximum value. So you can tell whether you have a maximum or minimum just by looking at the a, or the first term, or the x squared term. And in this case, it's positive, so I know it's shaped like a U, which means I have a minimum, and the minimum value is just the y value. So my minimum value is -1, because it only goes to a y position of -1 and then goes back up. So that's kind of easy to figure out. So A, B, and C are pretty much covered by this. Now the y-intercept, okay, that's the value. In other words, if we look at our function, if we look at our graph paper here, the y-intercept is where the function crosses the y-axis. And the x value, when a function crosses the y-axis, is 0. So the y-intercept is 0 something. That's the y-intercept. When the x is 0, what's the y? Well, when it's in standard form, it's real easy to find the y-intercept. If you look over here, let me put this over here. When x is 0, I have 0 squared plus 4x plus 3. So this is also y. F of x and y are interchangeable, so we could say y equals x squared plus 4x plus c. So in this case, when x is 0, y is 3. So my point 0, 3 is on the graph. So the y-intercept is 3. Or we could say the point 0, 3. So that's easy to find. Now the x-intercepts are a little bit more difficult, and we'll talk about that in the next video. And I'll explain the domain and range on the next video. But this should give you a pretty good insight on how to do most of it, and especially how to use this formula. X equals -b all over 2a to find the vertex. And again, if this is too small, you can always zoom in. And if you didn't understand anything or I went too fast, you can always pause it and go back. But make sure you thoroughly understand what's going on here.